notice that it follows a pattern. There's a couple of specific things that we want to look for when we're solving word problems. Your initial amount is going to be a deposit, a setup fee, a registration fee, a monthly fee, any starting amount. This could be, maybe you're taking a taxi ride. You have a certain amount for the first mile, so much for each mile after that. Or you're getting cable TV or digital or whatever it is. They come out and do your installation. You pay that one-time fee, then you pay what you're doing per month. That's what this is talking about. Initial amount is constant. This does not change. Right underneath that. Constant. Constant. For your rate, which in later we're going to talk about slope, this is what's changing. This is what's determining what your total amount is going to be. We want to look for something that has the words per, each, every, sometimes of, some each month, each day, each car, each person, per day, okay, or something like that. That's what's going to be multiplied by. So this is going to be changing. Quantity is always going to be your x. Changing by what? By the hour, by the minute, by the person, whatever it happens to be. Total is also going to be a constant. That's what it means, total. Usually you have a limit. You have this much money to spend, or a budget, or whatever it happens to be. How much can you do within that amount? So those are the things that we're looking for. So if we look at this example that they've already got worked out for you, Troy joined the fitness club, which will charge him $20 for the month and $2 for each hour he plans to use the facility. For the month. He has to pay that no matter what. Okay? That's his initial amount. There's our key word, each hour. That's how we tell that it's $2, and our quantity here is hours. That's the same question. How many hours can he use it? And so then here's our total. Solving is what we just got through doing with solving. So if we subtract 20 on both sides and we solve, then we can come down here and get 10. Because the opposite of 20, positive is subtraction. Remember, we have two sides of our equation here. So we subtract 20 from both sides. That's gone. Opposite of multiplication is division. Again, it's already written. And then you get 10. Check your answer. So if I put 10 back in my original problem, 2 times 10, 20, plus 20 is 40. So let's check. Another important part is you need to write this in a sentence. Because this is what tells you, did you find hours, did you find days, did you find money, what is it? He can use the facilities for 10 hours. And this is how you will see answers a lot of times on the STAR test. It won't just have a number. It'll ask you to do whatever it is, and your answer choices will be in the form of a sentence. You've got to pick out and know, what were you finding? Because it can have 10 in every choice, A, B, C, D. But is it 10 hours, 10 months, $10, okay, 10 people? And so you need to know what you're finding. So it's not just the number, it's also the particular item that you're using. So this says, the following problems can be solved in a similar manner. We want to write the equations to all of them. We want to check our solution, and we want to write our answers in a complete sentence. So, flip it over on the back. So, for buying a vase of red roses for Mother's Day, the florist charges $15 for the vase, $4.50 per rose. They want you to turn in an equation to represent the cost. And she said $51 to get the bouquet. They want to know how many roses can she buy. So, let's look at what we have. What is she going to pay no matter what?
$15 for the base.
Okay, so before she even picks out any roses, she has to have $15 that she has to pay for the vase. Then we're going to look for those keywords. Each, every, per.
It's $4.50 per rose.
So our rate
It's $4.50.
is $4.50, and our quantity represents what? For what?
Rose.
Rose. So this represents how many roses? Make sure you're writing them down. And she only has how much to spend?
$51.
So there's your equation. When you're writing an equation, you want to take it step by step. Look at the sentence that has the numbers in it and see where part fits this particular thing. Even when we get into solving systems of equations where we have two different things we're looking for, or two situations, it's going to pretty much be the same pattern. Almost every time. Okay, so if we're going to solve, what are we going to do first?
Subtract 15.
Okay, so I'm going to erase what I have wrote space here. And I'm going to take away 15. What am I going to take 15 from on the other side?
51.
Right. It has to be over here. Opposite operations. I don't want to take it from 450. It's not going to accomplish anything. Take it from both sides. So we end up with 50x equals 36. And what do we do to get rid of the 450?
Divide.
So I'm going to divide both sides by 450. And x is equal to 8. So if we check it, 450 times 8 plus 15 gives us 51. That's true. And what are we going to write as far as our answer in the sentence? What do we find?
The rose. How many roses
She
you
can
buy?
buy 8 roses.
Right. So she can buy buy 8 roses. Okay. So so when we write our sentence or write our equation, do keep in mind that we've got two sides here,
There are 30 tomatoes.
okay? And we want to write a sentence that says they can buy, or there are, something that indicates that you found 30 tamales. Found $30, 30 boxes, and 30 tamales in the box.
30 tamales.
Okay, the next one, this is the other type or other pattern of equations that you're going to have to write. So, if you look at these, this is not in an actual word problem, so to speak. There's a word sentence. You need to read each one. Most of them you can read in the order that you have. We have to be careful if we see the words more than or less than, because that's going to switch our order. But for this one, take each part. Watch the number is what?
2 times.
So you can use x, n, doesn't matter. What about increased by 4?
Plus 4.
Is
14.
and 14. So that's the number sentence that represents
It's 5.
that. Okay? And you probably can see it with that, but we need to maybe have the steps, because some of your question would just be, what sentence, math sentence, or equation describes this word situation? So then, like Jordan said, if we work it out and we subtract this on both sides, we're going to get 2x equals 10, divide both sides by 2, and x equals 5.
Yeah.
And we don't have to write this one in a word, in a sentence, because you're not finding a quantity of something. You're simply finding the number. So these are our two patterns. We start out with an initial amount, a rate, and a total, or we have a number sentence that we need to translate into an equation and then solve.